Hi everyone, welcome to topic 8. So this is our last unit of the term, and it's broken up into 2 weeks. So if we take a look at our to-do list, we have it broken down into 2 weeks worth of work. So we have our first week, so the first week we have 5 assignments due, and then the next week we have the rest of the assignments due. So just a reminder, we do have a final exam and it is cumulative. So we want to make sure that we're working on preparation for this final exam starting this week if you haven't started already. So I kind of suggest that you start working through topic 5. So topics 1 through 5 working this week. So looking through the study guides and things like that. Also, you should be signing up for your Zoom proctor sections or sessions for that. Okay, so that can be found under the final exam. So figuring out which proctor exam session that you can do with me. If neither of those work or none of those work for you, then your other option is to either go through ProctorU or through the CCC Testing Center. If you are not signing up with me, then you need to email me and let me know that you're going to do it with ProctorU. If you're going to do it with the CCC Testing Center, let me know what day. Okay, so what day of the week. So it would be, I think the exam opens on the Friday before finals week. So the Friday, Monday, Tuesday, Wednesday, or Thursday. Okay. And then another warning for this week, our assignment 5 this week is, it does require you to track your water usage for 2 days. So just a heads up for that. So don't wait until Sunday night to do that assignment because you won't have the data for that. And it's a 10-point assignment, so don't let that fall behind. Okay. Just a reminder, if you haven't completed your topic 7 quiz, you still have time. And then, of course, you have your Drosophila fruit fly formal lab report that is due tonight. So don't forget to grade your paper against the rubric before you submit it so you don't leave any important information out. So let's get into our assignments. So the assignments for this week. So let's take a look at our Moodle page. So just a reminder, we do still have a couple more long-term assignments that we're working through. So even though we have that Drosophila fruit fly assignment that is completed, we still have 2 more. The most pressing assignment that's coming up is our integration project. So that one is due a week from today. So with that assignment, I did post by a way YouTube video. So you can find the link for that in our announcements folder that will walk you through exactly what to include in your integration project. So make sure you take a look at that handout as well, so that it explains exactly what you need to include in your presentation. So you're creating a PowerPoint presentation. You need to have at least 6 slides for including all the relevant information per slide, probably more than 6 slides. This is the only time where you can have a file attached or a Google Doc attached to your post because just the size, it might not fit in the post itself. So you're welcome to attach it instead of having the slides attached. Okay, so it's up to you. This is a hard deadline, so you have to have it posted no later than June 3rd, so that's the Monday. Okay, if you post it June 4th, then I will not grade it and your fellow students do not have to look at it. So this is a hard deadline, okay, because other students will be reviewing it and asking questions about it. So if you haven't posted it by the deadline, then they might not see it. Okay, and then your final, well, it's not really a lab report, it's kind of more of a quiz. but it's basically essentially lab report put in quiz format. That's based on your long-term grass seed experiment. So you collected the data for that last time, or basically yesterday was the last day you collected that. So all that information is put into kind of a quiz. I'll talk more about that next week. I'll actually show it to you next week's video. But you can continue, thinking about what to include in your answers for that. So that's what that's all about. But let's get into the actual topic this week. So we're kind of, looking at human impacts on the environment this week. So we're in the Anthropocene era. So that's, anthro means man. So we're looking at the basically human influenced part of Earth's history. So we'll get into the reading assignment. So the reading assignment this week also extends into next week. So if you don't complete the reading assignment this week, it's not officially due until next week. I think there's 11 questions associated with it. So you can start working on it this week. The sections that are basically answer parts of the assignments due this week. So we have 5 assignments due this week. So S1 through S5. So let's take a look at the first assignment. So the first assignment, we're going to look at the human populations assignment. So with this assignment, we're going to be basically answering pages 239 through 242. Okay, so with this, we will be doing some using some outside resources as well as doing some calculations. So let's look at the outside resources. So we're going to be looking at class activity number 1. And with this, I pretty much, when I was looking through the course information, I was pretty much, I got all of my information directly from this 2022 World Population Data Sheet. So, you might want to do the same. I kind of just expanded it and used that. So if we look at the questions, what is the population of the world? Now notice this data sheet is from 2022. So obviously our population is more than that, but we'll just go with the 2022. That is fine. And when we're answering the questions, just answer it directly from here. So you can see here it says 7.96 billion, even though we have surpassed the 8 billion mark in our population size. Okay, let's see. So you can kind of see, look at the continents in order, some for least populated to most, what's the population in the United States. You can see that in our different sections here. So we can go down to North America. So this is in millions. Okay, so 332.8 million, so you can write it out as 332, so 332, 800, 000. Okay. And then we do have some calculations. In number 4, the calculation here is not what we want you to use. So if we go back into our calculations that we give you for our assignment on our Moodle page, it says for page 239, number 4, for doubling time, use this formula. T equals 70 divided by the rate of natural increase percentage. So this comes from the population data sheets. So we'll use this formula, T divided by 70 divided by rate of increase. Okay, so instead of this, we're going to use T equals, so it's 70 divided by R instead. All right. So if we go back, we're going to look at the United States population, how long it takes to double in size. So R is the rate of natural increase. So to find that, we'll go back into our world population data sheet from 2022. Okay, so we'll look at United States, and then we'll find the rate of natural increase percentage. So that was 0.1. Okay, so we'll just plug in the number. So T equals 70 divided by 0.1. So you can calculate that to figure out how many years it will take for the United States to double in time. So just calculate that out. You'll do the same thing for the world population. Okay, so go back into our world population. You can find that number up here. So here's the rate of natural increase. Notice it's bigger, so 0.9 instead of 0.1. So you'll plug that number in. So T equals 70 divided by 0.9. Okay. You'll kind of look at, do some statistical research. So list the 3 most populated countries in the world, list the average lifespans. So that's just straight looking at some of the statistics here. So figure out what's the most populated. So take a look, which is the biggest numbers here. And then the average lifespan for the United States versus the world. So you can see here the life expectancies for males and females, the total versus the United States. You can find that over here. So for males and females, total. Okay, so you're just basically using this document to answer the questions throughout. Okay, so that's pretty straightforward here. Okay. Let's see. We'll continue using that world population data sheet from 2022 to continue these calculations. So you'll look at the 3 countries with the highest birth rates versus the 3 countries with the lowest birth rates. So again, just go through which country has the highest numbers for their birth rates. So just look for the highest numbers in the chart, which have the lowest numbers in the chart. Okay, write those down, which 3. And then so forth. Which geographic region has the highest birth rate? Which geographic region has the lowest? Okay, so for this shaded area, what they're talking about, you can, you can use this as a guideline, but this other website, the population data chart, is what you can use to kind of look at that. So where it says choose a region, okay, so you can see Africa, you can kind of see the areas of Africa that have population. So you can kind of use the different data sheets if you want, or you can just use the charts that we were looking at earlier, and kind of figure out which area of the world had kind of the most births per capita. Just look at the general areas of the world. It looks like Africa pretty much had a lot. Compared to like Europe that had a little, that kind of thing. So you can kind of, put the 2 together and figure out, which geographic area had the lowest birth rate versus the highest, or whatever, okay? Then you can use the world's population birth rate, so you can calculate it. So you're looking at the birth rate versus the death rate. So from there, again, you go back into our table here, and you're going to see the birth rates per 1,000, so 17 per 1,000 and 8 per 1,000 for death rate. Okay, so birth rate minus death rate. So 17 per 1,000 minus death rate was 8 per 1,000. So what do you get? Okay, 17 minus 8 was 9 per 1,000. So that's that's basically, you know, what you're following here. And then from there, you're going to calculate the the rate of natural increase. So birth rate per 1,000 equals the natural increase per 1,000. Okay, so that was that 9 divided by 1,000, right? So from there, you're going to divide the natural increase per 1,000 divided by 1,000. So what is that? That's 0.009. And then from there, you just follow the calculations. You take that natural increase, multiply it by 1,000, then you get the percent, okay? And then from there, try to explain, you know, what's the difference between this number and, you know, what you're doing here, all right? Then you're going to do the same thing. So figure out what the birth rate for the United States is and the death rate for the United States and calculate the rate of natural increase. Okay, and then from there, explain, you know, is based on the rate of natural increase, do you think, is the population growing, is it decreasing, or is it remaining stable? Okay, so then you can kind of, you know, look at the major geographic regions and see if they're increasing faster than the world population. Okay, so just keep on answering the questions through that. So next we're going to look at the total fertility rate. So if we take a look at that column in our world population, so we're going to be examining this column throughout. Okay, so you can see, you know, for throughout the regions of the world, you know, if it's a relatively high number, so that means that the women are replacing themselves plus more, okay? If it's a low number, then the population is decreasing because the women are not replacing themselves and their partners, and the population will be decreasing from there, okay? So you'll kind of, you know, figure that out, as well as looking at the percentage of the population that is less than 15 years old and over 65 years old. So that'll kind of give us an idea of the structure of the population. Okay. Let's see. Here you're basically looking at the difference between the rate of natural increase and the total population. So how that will give us a prediction of what will happen in the future. So if we take a look at the population of China, and then we, you know, the rate of natural increase is basically the growth rate. If we multiply the two together, we're kind of comparing the two and seeing how, you know, how much the population increases every year. So we can kind of see, you know, compare China's population, which currently is larger than India, but India has a higher rate of natural increase. So when will India surpass China? Okay. So that is the first assignment in its entirety. So just be careful with this assignment. So, I mean, it's pretty standard. You're just going back and forth from this world population data table and your workbook assignment. Just be aware, though, that you have your student assigned role answers to post, but you also have 3 additional question answers to post. So everybody's posting the answers to these questions as well as their own. So that is due this Sunday. Next, we have our World Resource Consumption Lab. So now that we have an idea of the populations of different countries, now we're going to bring in the energy consumptions of different countries and compare the two. So everybody is assigned two different countries. So we're going to first examine the energy consumptions of 2 different countries. So we're going to go to the energy consumption link on our class activity number 2. Okay, so so we have basically these 2. So let's take a look at the activity. Okay, so we have our countries. So you were assigned 2 of them. Now, From when I actually had to do all of them. So the first thing, total population. Get the total population from the first activity, okay, reference. So when we go back to our world population data sheet, this is where you can get the population. Okay, so if you were assigned United States, or whatever country you were assigned, you can get the population from there. Okay, so if you're assigned South Africa, I just saw that. So 60.6, so that is 60,600,000. All right. If you're assigned United States, so that's 332,800,000. So that's where you can get the total population when you're writing it here. Go ahead and cross out this because website is down. I can't find it. I can't find the numbers for that. So, and I don't know, it hasn't been fixed. I don't know if anybody's going to fix it anytime soon. So I figure let's just cross it out. Nobody needs it anyway because we do have the per capita, which is what we needed anyway. Okay, so I'm going to go ahead and take executive action and just go ahead and cross that out. All right, so nobody needs to write that in. So now the only thing we do need is the So the only thing we do need is the per capita energy consumption. So that we do have available. Okay, so if we go back to our topic activities, we're going to go to this energy consumption 2014 equivalent. So it does, by the way, it takes you some time to load it. So ignore this thing. We're going to scroll down. So you're going to find whichever country you were assigned. So if you were assigned, I think the first one on the list is Brazil. So I can go down to Brazil. Okay, so you're going to record this number. So 1490 for Brazil. So 1490 for Brazil. Okay, so and then you'll write in whatever the population was for Brazil if you were assigned Brazil. Okay, so you'll write that down based on that reference, okay, from your activity list. So this is the first thing you'll do for for step 2. Is go ahead and post your results for your 2 countries. So just post that down below so that everybody has can go ahead and reference that and fill in their tables. Because once you can fill in your tables, then you can answer the next questions. Okay, so you'll need the answers to the questions to be able to fill out. Everybody has to fill out questions 1 through 4. All right. So, you'll need to compare and contrast the averages to the United States of the different countries. All right. So number 2. Number 2 is, I'm going to give you the not as accurate way, but the easy way to do this. All right. So, let's go ahead and do the United States together. Okay, so from basically the previous page, you'll write the total population for the United States. So the total population from the United States from the World Population Database was 332,800,000. So I'm going to write that down. So 332 million, 800,000. So I'm going to, it says here, multiply the population by the natural increase and divide by 100. So I'm going to multiply that by the natural increase. So if you remember from the previous activity, you will have calculated the natural increase for the United States. Okay, And I'm going to tell you now that, well, let's go look. The natural increase is 0.1, okay, for the United States. So 11 minus 10 is, 1. So 1 out of 1,000 times 100 is 0.1. So I'm going to write that down. Okay, so is 0.1. 0.1. Okay, then I'm going to divide that by 100. Okay, so that's going to give me 320,800. Okay, now so that's going to be my increase in population in 1 year. But I want to see what's going to happen after 5 years. So I could do this again. So add this to the population, multiply it by this, and then get the next number and do this over and over again for 5 years. But for simplicity's sake, I'm just going to take this and multiply it by 5 years and see what, I'll get for the population increase over 5 years, and then I'm going to add it back to the total. Yes, technically it's not going to give me the most accurate result, but it will get me close to it. So any mathematicians out there, go ahead and do it the real way and get the accurate result. But just because if any of you are writing this out in pencil, you're not going to have room to do it the accurate way. Trust me, I've tried. So I'm just going to go ahead and do it the easy way. And I'm going to take this number, 332,800, and multiply it by the 5 years. Okay, so I'm just taking what I got for, this is the number of individuals that were added to the population in 1 year, and I'm going to multiply it by 5 years. So how many individuals were added to the population in 5 years? And I get, how much do I get? I get 1,604,000. Okay, so this is how many people were added to our population in 5 years. Then I add this number back to our original population. Okay, so let's add that to our original population. So plus the original population was 320,800,000. Okay, so that equals, what was the total I got? I got 334,464,000 people. Okay, so this is my total. So after 5 years, my population in the United States increased. It was 332 million, now it's 334 million. Okay, it increased by 1.6 million. So I'll do the same for South Africa, I'll do the same for China, and I'll do the same for India. All right, so you'll do the same for that. Next, in question 3, we're going to look at the total energy usage per person. So estimate the population by the amount of energy per person. So I'm going to take this total population in the United States, USA, 334,464,000, and I'm going to multiply it by my energy per capita, which I didn't find. Okay, so what was my energy per capita in the United States? I have to scroll down to find the United States. So it's 6,804 times 6,804. So 6,804 per capita. So I forget what the energy. So million tons per person. So multiply that out, and you get how the total amount of energy consumption in our population. So you'll compare that to South Africa and China and India. Okay, and then you'll kind of compare our consumption, our population's consumption to South Africa, China, and India after 5 years. All right. So I'll let you do the rest of the calculations. Next, we're going to do the carbon footprints of our different countries. All right, so with our carbon footprint, we're going to use 2 sources. So this one, I had to use a couple different sources. So for one of the sources, we give you from our activity. So let me go back to our activity. So we're going to use the World Carbon Footprint and Environmental Footprint on class activity. So you can look at this carbon footprint quote, by the way. But otherwise, you're going to go ahead and use this document here. So you're going to kind of scroll down, and then you're going to look at this chart. So you're going to use whatever country you were assigned. Okay, so notice everybody has 2 countries that they were assigned. So the first one, Tanzania, I'm going to look at that one up. All right. And I'm going to look at their carbon footprint per ton, as well as the carbon footprint by goods. So let's take a look at the carbon footprint per ton for Tanzania. Okay, so their carbon footprint per ton was, it looks like it was only 1.2. Okay, so I would write 1.2. And then I'm going to look at, for their goods, okay, so what part of their goods, what part of their, how do they use their carbon, basically? Where does it come from? So I'm going to look at that distribution. So you can see, did it go through to construction, shelter, food, clothing, manufactured products, mobility, service, or trade? So if I look at Tanzania, it looks like, we have, I don't want to look at the population. Tanzania, where are you? So 1%, 45% looks like the highest number, and that was for food. Okay, so I would write 45%, and I also like to write the goods, so I write food. So it looks like, Tanzania you can think of as like a developing country. It's not, it's very impoverished. And so most of the carbon usage that they use in their country, or their emissions, comes from food. Okay, so they are, they're starving. They're, most of their carbon usage goes to food. Next, I got to figure out their total carbon footprint. So where I got this number, I go back into our activities, and I actually go back up here, and I use the CIA World Factbook for that. Okay, so this is the best way that I could find that information, because this website is broken. It says currently down May 2023, and somebody has not found an equivalent website. So I actually found my carbon emissions for the countries from the World Factbook. So use that one instead. So if you go down into the search button, you can type in your country. And then if you scroll down to energy, you can go ahead and look at carbon emissions. So here's carbon emissions. Now, for some countries like Russia and the United States and China, it doesn't say million, it just says metric tons, so you get this huge number, okay? So make sure you convert it into millions for those countries. Otherwise you get this huge number and it looks weird against all the other countries. So for Tanzania, it says 11.491. So I'm just going to round it to 11.5. So my total million tons or metric tons is 11.5 million metric tons. Okay, so that's what I'm going to do. All right. So again, because other students need this data to fill in the rest of the chart to answer the questions, please go ahead and once you have filled in your data, go ahead and post it in your forum so that other people can use it to answer. Everybody has to answer number 5 and 6. Okay? Number 5 and 6. All right. Next, you're going to calculate your ecological footprint. So this is a way that you can kind of see what your personal footprint is. I always do this. I probably do this about once a year just to see where I can improve and, you know, reduce my carbon footprint in the world. So when you go in here, you're going to go down to world resource consumption and you're going to calculate your personal footprint. Okay, there are a number of different footprint calculators out there, so we're going to use this one. Okay, so you can go ahead and click on the footprint calculator and make sure you click on the language that you prefer, obviously. Okay, click on the box, take the first step. Okay, now you're going to go through and answer the questions. Okay, so you can kind of answer it based on your you know, what your preference is for each one. If you want to add more detail, you can do so. Okay, you don't have to. Okay, if you don't really know the answer, so some of these you might not know the answer to, that's okay. Okay, so like for example, how much of the food that you eat is, you know, some of you might not know if it's locally grown or not. So you can kind of just do right in the middle. All right. At the end, I can't remember if it's this, I've done this for multiple classes, so I can't remember which website does this, but it might ask you to give your email address. Okay. So you can just give whatever email address you want. It doesn't have to be your student email. They just, I sometimes, you know, everybody has a junk email where you just submit to, you know, whatever the companies that you don't really care about. You can do that one. But yeah, they just want that for whatever reason. Okay. So, but once you do answer all of the questions, then it'll spit out. I'm just trying to, you know, do this quickly. So it'll give you, actually I don't think you have to skip to view my results to see. Woohoo. Okay, good. So that one, it didn't actually make you have to do the email. So I know some of those footprint calculators do make you. So it gives you some results here. So it says that if everyone lived like me, we would need almost 3 Earths. Wow, that's a lot. Okay. And then it says my personal Earth overshoot day is May 3rd. So that means that by May 3rd, I've already used up more carbon than than I should have. Okay, so after that, I have added more carbon into the atmosphere than I should. Okay. So from there, you're going to just answer the questions. So when it gets down to things like this, then you can go ahead and look at the details. So here it says see details. So here is the global hectares. So 4.8 global hectares. So that'll give you that answer. So how much global hectares, how much carbon dioxide did you produce? So that should be given here. Okay, so this is your CO2. Okay, here's your carbon footprint. Okay, what can you attribute your largest percentage? So all of that information should be here. Okay, so you can kind of answer those questions based on that. Let me see if there's anything else. What simple actions can you take? So for that question, you can actually go into solutions up here. So some of these are pretty easy solutions that you can take. So let me see. I can't remember. No. I'm trying to remember. I haven't done this one for a while, so I'm trying to remember what you can do. Oh, explore your data. That's what it was. Let's see. No, it wasn't. Okay. Consumption by category. Let me see if I keep going. I remember there was something where you can actually go into I guess you can just read through and look at, oh, so here it says you can move the date 8 days by reforesting. So what are some of the different ways you can do that? So you can do classical conservation. So, efforts to protect wild spaces, restoration, regenerative agriculture, sustainable. So these are some of the solutions that could perhaps move your date. Okay, so there are ways that we can actually move our date. Move it 13 days if we cut food waste in half worldwide. 17 days if we reduce the amount of meat consumption by 50%. Okay, so replace the calories with a vegetarian diet. Okay, so those are ways that we can move our date. So that is what we can add for simple actions you can take to change your footprint, and how much those actions can change your footprint. So how it can move that date. All right. So that is our third assignment, or is that the second assignment? Jeez. It's going to take you a while. Lots of, kind of back and forth work. All right. Well, this one's pretty easy because you're going to basically watch a video. So you're going to watch a video on GMO plants, and then you're going to be answering the questions along the way. So this is, I think it's quite an interesting video on GMO. So these are the genetically modified organisms. So they're going to give you some examples of GMO plants. You probably will actually be surprised at how many food products that you eat actually have been genetically modified. So, and you'll see like the pros and cons, and what society has kind of projected on the GMO movement. So we're kind of giving some information about it. Next, you're going to take a look at the process. So what is genetically modified mean, and how does it work? So we're actually going to look at the science behind it, and we're going to look at DNA isolation and PCR simulation. So with that, we're going to take a look at a simulation. So going down into this activity, so we have basically down here with this virtual lab. The virtual lab it's pretty fun. You get to, try it yourself. I'm sorry, not try it yourself. You get to go through this lab virtually, so you actually get to kind of play along, read the information. Okay, press next, follow the directions. Genetic testing, you're gonna play around with a dead body. Okay, analyze, basically you're going to, go through, extract DNA, amplify it with a technique called PCR. So that's polymerase chain reaction, and then learn a little bit about the whole process. I'm not going to show you it on here. So this one, you're just doing PCR and DNA extraction. And then I think next time we're going to do the gel electrophoresis. Oh, we are going to read the directions and examine the gels as well. Okay, so that read, so you'll do the DNA isolation and PCR, the little virtual lab, as you go along, answer the questions. So it's pretty easy. You'll play along with the little gel electrophoresis as well. All right, so that's the third activity. It's straightforward. All right. All right, and then, so that's page 2. Okay, so then next we're going to be looking at, we're going to apply this to the GMO crops. So we're going to take a look at some GMO corn and soybeans. So these GMO corn have been, basically they have been genetically modified to have Roundup ready in there. So Roundup is a, basically it's a pesticide, right? I can't remember, pesticide or herbicide that, so it protects the plant. So you can spray a bunch of herbicides and pesticides on these plants, but the corn is protected against it, so it's not going to die no matter what. And so these will be protected against it, so they have the gene present. So whereas the wild type, or the ones that don't have that particular gene, they, if they're subjected to Roundup, then they will die. Okay, so you're going to kind of take a look at the results of the gel electrophoresis, so you can kind of see what a GMO related gene positive control will look like. So the bands are placed here. Okay, the bands of interest would be here. So if we look at the positive, it would match up. Okay. If it's a negative, it wouldn't match up. So you can see where the positive is versus a negative. They're not on the same line. Okay, positive, negative. So then you would be able to see, which ones would be the GMO food and which one would not. So which would be a positive result, which would be a negative result. Okay. And then finally, we get into the fourth activity, the identification of GMO crops, part 1. So we'll be providing the results. It's not a wet lab this term. So this one, you're simply just going to be writing a hypothesis on which foods have been genetically modified. So we will post the instruction results online, and we'll complete the actual lab later on. Okay, so that'll be next week. So for this one, you're just basically writing your hypothesis. So you're going to read the information, and here's the question. What foods contain genetically modified DNA, and what percentage of foods tested by the class contain genetically modified DNA? So you can kind of see these are the ones that are most likely going to contain contained the modified DNA, GMOs. And then as far as so as far as since we're not actually doing this experiment, we're relying on data from an in-person class. So what these students did is that they brought in soy or corn-based snack foods. So you can think of like soy or corn-based snack food that students would bring in would be like different types of chips, or like popcorn, or like breakfast bars, or that kind of thing, that were brought into the classroom. So snack food, think of snack food. So think about what you might have in your own pantry. So what type of snack foods would you think would contain, do you think would be like GMO, contain GMO food? Do you think it would be like, think about like the foods that you get at the grocery store versus more of like a Whole Foods market, organic, that kind of thing. Do you think the organic foods would contain the GMO foods, or would it be more of like the foods that you go to Safeway, that kind of thing? Is there a difference? Do you think, would it be any different based on which type of market you go to? And then what percentage of foods tested by the class do you think would contain modified DNA? So you might kind of think of like, what are the key words that you see on some of the products when you shop? If it says natural, does it actually mean GMO free? If it actually says GMO free, do you think it is GMO free? So there's a lot of, questions that you might want to think about when you're creating your hypothesis. Okay, and that's basically all you need to include is here. So just write a hypothesis of the foods you think would be considered genetically modified or would be genetically modified. Okay, so that's all you have to do here. And then finally, this is the big one. This is the one that you're going to have to basically write a diary for 2 days on how you're consuming water throughout the day for 2 days. So here is your chart that you're going to take with you. So basically, think about, the amount of water that you drink throughout the day, bathing, showering, teeth brushing, hand washing, all that stuff. So you might just want to do a tally mark every time you take a drink, bathing, showering, and then kind of equivalent that with the amount of equivalent amount, and then total that up. And then that way you can kind of do the total amount over the time. Okay. All right, so the next you're going to be watching video, so freshwater, why we care about water, and freshwater story interactive, so answer the questions. So the first question, A through F, so you'll answer that based on this interactive, and the hidden water usage, A through E, and number 2. This one, by the way, where is it down here? A through E. What was it? The hidden water usage. Sorry. Getting confused here. Hidden water usage. How much water does a cake? Oops. Now, if you look at this chart and you look at the chart here, you'll notice that some of these don't match up. So, for example, we don't have milk in our chart, so I would just cross that out and put cross that out and put in coffee instead. Coffee. Also, let's see. Instead of rice, I would cross that out and put corn. Okay. And I wrote that, by the way, in the instructions, because I noticed that earlier when I was, trying to figure out the answers and I couldn't find them. So change milk to coffee and rice to corn, because otherwise it doesn't have them there. All right, so you answer those questions on page 262, page 263, use the previous information from your personal water diary and the interactive. And then for pages 265 to 266, you're going to watch the JZ diary in Africa to answer those questions. So here's the working link to those. All right. And then, we have more questions and answers there. So what water supplies refer to that. We have interactive there, social issues with the JZ videos. All right. So I'm trying to just go through this as quickly as possible. So because we have all of these things that are due by Sunday midnight. Okay. So once you have answered all of those questions, go ahead and post your answers on our Moodle page here. And let's see, I don't think there is anything special about that. Nope. Okay. So that is it. So we have these 5 assignments that are due Sunday midnight. And then don't forget you have your integration project that is due Monday following, so June 3rd. All right, if you have any questions, feel free to email me. Otherwise, good luck, everyone.